Greetings and welcome, friends. Mr. Waddy here and my fellow algebraticians. They're putting their fidgets away so they can do some algebra. It's going to be good. It says this: tell whether the ordered pair is a solution of the system of linear equations. Now, if I plug this in for x and y, I can check to see if it works in this equation, meaning if it does, it will make the equation true and it will be a point on that line. If don't give us the answer yet, no spoilers. If it works in this equation, it will be a point on its line, and it'll make that equation true. If it's true for the system, it will be true for both equations at the same time. So let's plug in the 3 for y, the -1 for x, and now just PEMDAS this. So positive 7 minus 4, I get 3 equals 3. That is a true statement. That means it is a solution to the first equation. I have no idea. Don't spoil it. Don't spoil it now. So let's see. For the second one, plug in 3 for y equals 8 times -1 Devin plus 5. Let's simplify. 3 equals -8 plus 5. Oh, 3 equals -3 is a no-go. So because it does not work there, when I combine these two, it is not working for the system. By the way, a solution of a system of linear equations will be a point where both of the lines exist. You might call that an intersection, right? And we'll see a graphical representation in this next problem that I chose. Question 11 says, use the graph to solve the system of linear equations. So here's these two equations modeled graphically. Where is their intersection? No. Well, this is where they cross. So -4, 7, -4 comma, what's the y coordinate? 5. All right, so -4, 5 is the intersection of those two things. For sake of time, I'm just going to check one of these. I'd rather get some more interesting problems today. So 6 times y plus 3 times -4, is that equal to 18? And now with solving graphically, sometimes these aren't exact. They're not the most accurate. These graphs, sometimes, it's going to end up being two numbers that are decimally close to each other, perhaps. But yeah, it does work in that. All right, I'm on a roll. I'll do it in the other one as well. The opposite of -4 plus 4 times 5, is that equal to 24? See, Cameron, you writing this down? 4 plus 9, is that, that's not 9. 4 plus 20. 24 equals 24. Because it works in both of those lines, it is a solution of the system. So our solution checks out, and that is our solution. You can represent it as an ordered pair like I did, -4 comma 5, or you can represent that as x equals -4, y equals 5. All right, so we've been increasing in complexity one after the other. All right, let's to graph these, let's find the slope and the y-intercept. So the slope of line 1 is what? 1/3? Don't give us the answer yet. No spoilers. Come on. We're all about the process here. It's all right. It's all right. M2, the slope of line 2. What's the slope of this line? 2/3. And slope is rise over run. So that's going to be right up to over 3 when we get to that point. What's the y-intercept for this one, for the first line? +2. So if I want to graph that, I'm going to go to 2 on, oh, wait a minute. Which 2 do I go to? Yeah, the y-axis is 2, so it starts there. Then I move by my slope, which is 1/3. So up 1 and over 3. And up 1 and over 3. I guess I should also put points along that. And yeah, and I can get some more if I want, right? Like so. And then we draw the line. through those points. I like to try to line it up with the points that are furthest away from each other. Your line will tend to be more accurate as a result. A little less exaggeration and error shows up. So here is my first line. So that's this line right here, line 1 I'm calling that. For my second line, I didn't ask this yet, what is the y-intercept of this second line? That's 5. So we'll start up at the 5 on that axis, and we'll move by the slope. So up 2 over 3. We always run to the right. Mario typically runs to the right. So up 2 over 3. Let's do it again. Now, is this seems like it's getting further from the other line. Yeah, this line will continue backwards as well, so maybe they'll cross over here somewhere. I hope so. I hope so. All right, let's connect these dots. All right, now the accuracy. Let's be friends. Let's see. Is this gonna line up right? Devin, I got my job. You do yours. You write this down. So let's see. I don't know. Maybe that's not the best point. Maybe I'll try this one. Okay. Yeah, this is one of the challenges with graphing. Is it's hard to do it super accurately, and then when I'm trying to read my solution, right? It's kind of like I don't know. That's kind of hard to read. Let's zoom in a little bit. It looks like my solution is, I don't know, like maybe it's supposed to be -8, -1. I don't know. Maybe it's around like -7.5, -0.5. What do you guys think? What did you get for this one, Pooja? Oh, all right. Did I at least got my graphs right? They're just probably sloppy. So I'm going to call this like -7.5, -0.5. Something like that. But this is one of the challenges or the weaknesses with solving by graphing. There are better, more accurate approaches that we can take. And that's one of the things I'll be showing us today. All right. Let's look at this one. Ooh, this is where using technology, you can be a little bit more accurate with graphing. Also, I would not want to have to graph this by hand. No, siree. So let me pull up some Desmos here. Ooh. So 25. I'm just going to write these two equations into Desmos. If I was to graph these by hand, I would either use the Intercepts method, or I would have put it in y = mx + b, try to find the slope and y-intercept as best as I can. So let's see. So I've got -7x plus 6y equals 0. Gentlemen, please. So here we go. There's our first equation. Our second equation is 0.5x. So 5x plus y equals 2. And the cool thing about Desmos is if you click and drag on a line, you can actually find all of its solutions, or at least out to a few decimal places, and see that. Also notice that when I have this line selected, I have 3 gray points here. I could actually find out what the x and y intercepts are. And since I have multiple graphs here, I can actually find the solution of multiple equations simultaneously. All right, so that's pretty good stuff. So the solution of this using technology, which graphing calculators can do this as well, but the solution here would be 1.2, 1.4. And if I plug those values in, they actually should, in this case, work out exact. So yeah, super easy to do this with Desmos. All right, last problem. Last problem. This is the toughest. A word problem. With words, we're going to need word answers, and we're going to need to define our variables for starters. The variables are usually the question that it's asking. It says, how many of each type of candle did you sell? All right, so let's let X equal the number of, what's the first type of candles? Small. So number of small candles. And let's let Y equal the number of large candles. And you guys are welcome. I gave you this graph pre-made so you didn't have to figure out intercepts before you even figured out the scale of your graph. Oh, we'll see. I hope I'm all set. We'll see. I might also, depending on what you called X and Y, like for instance over here I go far enough to the 36 if that's what you're saying. So let's write our equations first. Before we even get there. So, first equation is going to be related to these variables and some fact pulled from the graphic and the words here. It says the following: you collect $144 selling a total of 28 candles. Now, over here, it actually tells me the price of each type of candle. So, it's $4 each for the small candles. So if I want to figure out how much money I had coming in, Ethan, you should write this down, from the sale of just the small candles, I would take the price I made per candle and multiply by the number of small candles. I would then take the price per large candle and multiply by the number of large candles, Y. This represents how much money people gave me for large candles. If I add those together, that should be the total amount of money I made, which is $144. There's my first fact, and I write my first equation from that fact. My second fact is stated a lot more briefly. I sold a total of 28 candles. Could someone help me write an equation regarding the 28? Yeah, regarding this purple fact. Wow. I don't think that's as obvious. Right. This is how I would have interpreted it, and then I would have eventually changed it to what you said. So yeah, the number of small candles plus the number of large candles should equal the total number of candles. So X plus Y equals 28. So those are our two equations. Let's graph these. Let's graph these equations. Now the x-axis is small candles, right? And the y-axis is large candles. Ethan, you should be writing this down and stop playing with my awesome French curve there. They are awesome, yeah. So to solve this, I like what Pooja had suggested. Let's solve this for y, put these in slope-intercept form. Or, actually, you know what? Let's do both. Let's graph the purple graph using slope-intercept form. So I would have subtracted x from both sides, yikes. And I would have y equals negative x plus 28. And then the other one we'll do using intercepts method. We haven't done that in a long time. All right, so the slope here is, what is the slope of this equation? It's tricky. Yeah, the slope is -1. And what's the y-intercept? B is equal to 28. So I'm going to go up to 28 for my y-intercept, my starting point, and go down 1 over 1. Now I could try to go down 1 over 1, down 1 over 1, right, down 1 over 1. But if it starts at 28 up here and goes down 1 over 1, where do you think it's going to cross on the x-axis? It's actually, going down 1 over 1 is the same as going down 28 over 28. It's actually going to cross over here at 28. Let's draw that line. You also could have gone down 5 over 5 or down 4 over 4, whatever numbers you picked. Man, it's showing that right in the way of where I need it. Not helpful there. Okay, so let's draw the purple line. Now, notice I picked our coordinate plane. Should I extend this past the x-axis, or past the y-axis over here? No. Can you tell me why? It's because I can't sell a negative number of small candles or a negative number of large candles. That's why. All right. So that's why I restricted my graph kind of to the first quadrant where all of the x's and y's are positive. All right, for this one, 4x plus 6y equals 144. This looks very calculator necessary. Let's find the x. Let's do the intercepts method to graph this. To find the x-intercept, do you guys remember what we would do? How would I find the x-intercept? Do you guys remember? I would plug in 0 for who? I plug in 0 for y, right? Yeah. This might be easier in this case, I don't know, rather than working with a negative, what would that be? Negative 2/3 slope. So 4x plus 6 times 0 equals 144. 4x equals 144. Divide both sides by 4. We will, yeah. I'm just showing a different way to graph that I thought might be interesting for this. I got x equals 36. And so that is the x-intercept. That point is over here. Oh, it's an old concept that's not necessary. You also could have put this in y equals mx plus b. I just figured I'd do a little flashback for us for fun. But yeah, the way I find the y-intercept is plug in 0 for x. So 4 times 0 plus 6 times y equals 144. So yeah, no one in the class used this strategy. I just thought it would be, it sometimes is an interesting way to do it. So 4 times 0 is 0. To get y by itself, Jimmy, how do you think we could do this? How do I get rid of that 6? Yep, divide both sides by 6. And I think, is y going to equal 24? Did I do that right? You can ask a calculator. 144 divided by 6 is 24. So that means that's my y-intercept. I'm going to scroll up to 24. So my blue line is right there. And so, or the blue intercept is right there. Man, I keep putting that right in the way of what I need to see. All right, so let's connect these dots. And once again, I cannot sell a negative number of large or small candles. So looking at this graph, what is my solution? Well, it's going to be the intersection between these 2 points. It looks like either it's going to be, what is that, 12 or 13? Probably 13. I know it's got to be a whole number because I can't sell fractional amounts of candles either. And then how high does this look? Okay, that's a really good argument. So it looks like it kind of landed on 13, 16, but I just had a student say, I think it's going to land on the 12, and this is a really great logical check. They said because 12 plus 16 is 28. And I think I agree, yeah. So it's probably 12, 16, and this is, once again, the vagueness of solving by graphing, right? So it's kind of like, I wish I had a more accurate solution, right? This is a perfect advertisement for what we're learning today. If this was like, you know, as seen on TV product, have you ever had a hard time solving for the number of small and large candles exactly? I just can't get an accurate answer, right? And then I'm going to show you the better way to do it. So here's 12, 16. What does that mean as an answer? So yeah, we sold 12 small candles and 16 large candles. And if I didn't remember what that represented, where could I have found that out? at the, yeah, I guess the original question was asking me the number of each type, right? How many of each type did I sell? And then also, if I just take a look at the way I define my variables, if I define my variables well, I can then just plug those values of, right, 12 and 16 in for X and Y. 12 is number of small candles, 16 is number of large candles, and like, this would practically write its own answer. All right. Well, thank you for watching, Internet friends. Have a great day.